All right, hello and welcome to the end of chapter 3. We have reached the finish line in this chapter. So we've gone through a bunch of concepts, and we're going to use today as an opportunity to solve these problems, refresh ourselves on the things we may have forgotten earlier in the sections, and get ourselves prepped, ready to go to do well on our test tomorrow. So we will have a few examples to get to, so let's jump right in. So our first example, we want to know where does the graph that we're going to get, where does it intersect the x-axis? So there are a couple things we need to know. First, it's helpful to have some kind of a graph. So on your test, you'll of course have graph paper. You'll have a little coordinate plane there for you. But just so we have an idea of what we're talking about, let's draw a little plane. We want to know, where does this graph, given, where does it intersect, so where does it cross the x-axis? Now we know x-axis is the horizontal one, x. Our y-axis is vertical. So where does this graph cross the y-axis? We know it's going to be, it has a y-intercept. If I change my color, we know it has a y-intercept of -18. That is B, our y-intercept. It also has a slope of -3. That is the m. Of course, this is in the form y equals mx plus b. So we've used that form a lot. We're going to keep using that to help us with linear equations. So b is a -18. So we're going to be way down here at -18. Let's say that's -18 right here. Now we know it's going to have a slope of -3. So negative slopes go up to the left. So we know our slope should look something like that, going up to the left. Now the question you're asked is, where does this, what point does this occur at? At what x value are we crossing the x-axis? So if you graph this perfectly on your coordinate plane, you'll be able to see this value pretty easily, or perfectly. But since we didn't do that on this example, the second way that you can know how to solve these is by setting y equal to 0. Because when y is 0, that means you have to be exactly on the x-axis. Okay? So this is the point where y is 0, so we can find out what that x must be. So we can say 0 equals, and then we keep everything else. Now what do we do next? We can add 18 to both sides. So if we did that, we'd have plus 18, plus 18. This goes away, and on the left we will get just a number. So we say 18 equals -3 times x. Now one more step needs to happen to get x alone. We can divide both sides by -3, and x would equal a -6. So what is the value at this point? At this point, x equals -6. So that is the x-intercept. That's what we're asked to find. So -6 for example 1 for our last bit of notes on chapter 3. All right, so we're getting warm. We worked through that example, so we know how to find some intercepts. Example 2, our focus is now on finding the slope. So given 2 points, you can find the slope. Slope is m. Now, what formula do we know that allows us to plug in the values of 2 points to find the slope? Well, the name gives it away. It is the slope formula, and it is written as m equals y2 minus y1 over the difference in my x's, x2 minus the first x. So we'll have the difference in y's over the difference in x's. That's going to be equal to our slope m. So what we need to do now is label these points. One of them I want to be first and the other one will be second. So let's say I just label this one as my 2's. So I have x, I have y, I have an x, I have another y here. And I said I will call these ones my 2's. So x2, y2, x1, y1. So we have those. Now we have to just make sure we plug in the right thing, keep them in order. So y2, take away y1 would be 7 minus 4. So hopefully we're following along with that. Bottom, x2 minus x1 is 3 minus negative 1. Good. Now let's simplify that. 7 minus 4 gives me 3. Okay. And 3 minus a negative 1 is the same as 3 plus 1, which we know is 4. So what is the slope of the line through these points? It's simple. It is 3/4. That is our slope. That is the m value. So finding the slope with points, use this equation. And again, we call this the slope formula. And you should have that in your notes from much earlier in our discussion of chapter 3 things. So slope formula will definitely come into play. All right, so we've worked through a couple things. Now we see another one where they ask us to find the slope, but notice we don't have any numbers. They just say, what is the slope of any vertical line? Okay, so what do we know about these kinds of lines? So there's two kinds of lines you can have. You can have a line that's perfectly horizontal, and you can also have a line that is perfectly vertical. These are the two special cases of lines. Now remember when we were introducing slope, we talked about how a flat incline, such as the ground, the classroom floor, anything like that, those flat things have a slope of 0, right? Because there's no incline. So this is a slope of 0. A horizontal line is a slope of 0. So then what is a vertical line? It's very, very steep. We can see that. But what numerical value can we assign to that slope? Well, we talked about how this is a special case, and it would be impossible for me or you or anyone to try to walk up a vertical line. So we call that slope. It has a special term. If you don't remember, hopefully this refreshes that. We call that undefined. It's undefined because vertical slopes don't have a numerical value. Those things are strange. We call those undefined. So that is our solution. Any vertical line, anyone and everyone will have an undefined slope. So 3 is just remembering that rule. Vertical lines are undefined. Now, so if you see one such as that asking about vertical lines at any point on your test, you will now know those mean undefined. So the fourth example for our review session, we see we have 4 options to look at. We want to know which graph has a slope of -3. So the idea here is to identify our slopes given these pictures. So what do we know about slopes? We know a positive slope goes up to the right. We know a negative slope should be tilted the other way, going up to the left. So given what we see we have a slope of a negative number. So it should be tilted going up towards the left. So anything that's going up to the right we know has a positive slope. So F is wrong because this is a positive slope. It's tilted to the right. G, also wrong. It has a positive slope. It's tilted up to the right. Now H is negative and J is also negative. So now the objective becomes which one of these two has the correct slope quantity-wise. They're both negative, but one is the wrong value. So let's track the changes here. We have to remember that slope is change in y over change in x. So change in y means our vertical change up and down. So if I look at example choice J, let's start at the origin and track between that point and the tip of our arrow here. How did we change vertically? Well, we went up 1, 2, 3. So I'll put a 3 here. How did we change going left and right? Well, we went from here to here. We went 1 unit to the left. But to the left is negative on x, because going left is negative, right is positive. So that's a negative 1. So 3 over negative 1. So the slope of j is in fact a negative 3. And for your information, the slope for h, this is a negative 1/3. So they try to trick you with that. So the answer is j, that has the correct slope with the right incline. It's going up to the left, so we know it's negative, and that all checks out. So for example 4, it is this image here. So draw yourself a little picture of that. Have the step we solved for that slope as we move to the next one. So the fifth type of example, we talked about how to solve these sequence problems. And these are nice because we can just track the changes between our numbers, and we can find any term we want to. We have the tools ready to do that. So they want an equation for any term, for the nth term of the sequence. So we learned, and this is in our notes for the chapter, that any term can be found with the equation a sub n equals a sub 1 plus n minus 1 times d. Now what do we do here? Well, we know there's a couple things we need to plug in. So a sub 1 just means the first term, and d is the common difference between our terms. So if we look, we can figure out what these things are pretty fast. So a sub 1 is the first term. So which number comes first in this sequence? Well, we know that's 12. And what is the common difference? How are these changing every time? Well, I see they're going up by 3 between each one. So d is a 3, and it's positive. So now I can take these things, plug them in, and substitute into my equation. So a sub n will equal now 12, and 3 will go here, and then everything else will stay the same. So 12 plus n minus 1 times 3 gives us all of these things. Now we can multiply and make this thing a little simpler. So let's distribute the 3. So we would have 12 plus 3n minus 3. Now we can bring 12 and the 3 together. So 12 minus 3 is just 9. So I know my last equation with one more step is 3n plus 9. Now notice I could write 9 plus 3n, but we always want to write the n first with our variable and leave the number just at the end. So this is our equation. We can now use this to find any term in our sequence. That's the rule to find any term we want. Plug in the number of the term, multiply by 3, and add 9. So you will use that in our next example. So they ask us, what is the 12th term in this same sequence? So we just said we know a sub n equals 3n plus 9. So they ask us to find the 12th term. In other words, that means when n, the number of the term, is 12. So now we just substitute. Everywhere we see an n, we change it to a 12. So a sub 12, which now means the 12th term, will be equal to 3 times 12 plus 9. So we have those things. Now can we multiply and can we add to make this simpler? And we can. 3 times 12, we should have that memorized, is 36. If we add 9 to that, what will we get? One more step in your head or in a calculator gets you to 45. So the 12th term has to be 45 based on this rule of increasing by 3 each time. So 12th term is 45 using the rule we just found on the last one. That's our rule. And then we plugged in and we got the 12th term right here. So you could do any term you want, but they asked us for 12th, so we found it to be 45. So use that rule and have that down for the 6th example. All right. Now we remember we talked about some things varying directly. So we talked about the cases where we have y equals k, some number, times x. These are always what we call direct variation. So when you see this varies directly phrase, that means we're going to use y equals kx. Y equals some number times x. So they say y is 26 when x is 8. Find x when y is 65. So we need to know what k is. We need to solve for what that constant is supposed to be in this rule, in this relationship. So we know normally y equals kx. But they tell us y is 26 and x is 8. So we can substitute those things in. So y is 26. And we don't know k, but x is 8. So we have 8k equals 26. So we can divide both sides by 8. And we'll find that k equals 3.25. Feel free to check that in the calculator if you'd like. So the k, the constant, is 3.25. So what do we know the rule actually is for this relationship? Y equals 3.25 times whatever you put in, whatever x is. So now, using this as a rule, we could find whatever values we want given one of them. So they say find x when y is a 65. So we plug in a 65 for y, equal to 3.25 times x. And now, with one more step, we can divide both sides by 3.25 because we don't want that by the x. So this will go away here. We'll have just x. And it'll be equal to, let's check this in a calculator. 65 divided by 3 1/4 will give us a nice number, 20. X is 20 based on this relationship. So remember, if ever you see varies directly, that's going to mean use y equals kx. So example 7, x comes out to be 20 using that rule. Now, we will also have a few that say standard form. And we know standard form means we have those numbers next to our variables. They're on the same side of the equation. They're equal to a constant. So a, b, and c are all whole numbers, and they're equal to some constant. X and y are on the same side. So in other words, we need to rewrite this and have our 2x, we want that on the left side with our y's. Okay, so let's do that. So we're given to start our blank equation. Now we want our x's on the same side. So let's add 2x to both sides. And see what happens here. So -2 plus 2 becomes 0, so this goes away. On the left, we're going to get 2x plus y plus 1 equals now a negative 3. So we have our x's and our y's on the same side, but we have this constant here. And notice in our standard form, the only thing on the left side is your variables. That's it. There are no hanging numbers by themselves. All the numbers should be combined on the right side. So x and y, we don't want the 1 though, so we'll subtract that. So if we subtract 1 from both sides, this now goes away. And we'll have a negative 4 on the right. So 2x plus y equals now a negative 4. Now is this in standard form? Some number times x plus 1y equals a constant? Yes, that is perfect. That is exactly what standard form looks like. That's what that means. So example 8 is given here. 2x plus y equals a negative 4. So please have that down for our 8th example. Standard form is important. You'll have a few like that on your test and your study guide. Now, the 9th example. This is very fresh because we just talked about this concept in the last section we covered. So finding a root of a given equation. A root is the same thing as a 0. So all these phrases are interchangeable. We used 0 a lot yesterday. Root means the same thing. Also, it is the x-intercept of your graph. So we can solve this for x to find the root. We could also graph it. So either of those two strategies would get us there. So if 5x minus 20 equals 0, we can add 20 to both sides. And 5x would be equal to positive 20. So if we divide both sides by 5, x would equal 20 over 5, which we know is 4. So that is the root of that equation. The second way you could find it is to draw yourself a graph. If you do this on a coordinate plane where you're graphing precisely and accurately, you could say this is a y-intercept of negative 20, so you'd be down here, and then a slope of 5. So we know our graph would look something like this. And we see it cross the x-axis at a positive value. And this value, if you graph precisely, would be at x equals 4. So either of those two ways you could use to find that root. But we know the answer for this one is 4. That is the root. That is the solution. We can check because 5 times 4 is 20. And 20 minus 20 is 0. So that checks out for example number 9 today. Now one more thing to look at as we review all the things we've discussed. We can write an equation in function notation for this relation given below. In other words, given a graph, we want to write the equation, and instead of y, we'll write f of x. Okay, so there's two things we need to find. Normally we write our equations in y equals mx plus b form. And there are two unknowns in there that we need to have for our equation. We need to find out what is m, what is my slope, and what is my y-intercept, that is b. So where does this graph cross the y-axis? Well, it crosses is on the left here, and then it hits here, and then it's above here. So it crosses right at 0, right at this point. So I know b equals 0. Now what else do I know? I need to find my slope, m, even though we already found b, so now we need to find m. So what is my slope? So from here to pick any other point, let's say I pick this point. I'm going to track the changes between these 2 points. So here I see it goes up 2, that's positive 2, and then it goes left 2, that is a negative 2. Because going to the left for x is negative. So 2 divided by negative 2, my slope is change in y over change in x. So my change in y I said was 2. That's my rise. My run was a negative 2. So 2 over negative 2 is a negative 1. So that turns out to be my slope, a negative 1. That is m. So now I can take these two things that we just found and replace them in my equation. So we know y equals negative 1 x, and we said b is 0 plus 0. Now there's a couple things in here that we would never write. So we would never write plus 0, we would actually just leave it blank. The other thing is we don't write negative 1x, we just write negative x because the 1 is assumed. You already know that that's there. So y equals negative x. So that's good. But remember they said they wanted it in function notation, which means instead of a y, we need to write f of x, like we see there. So we'll change the y to f of x. We know those things are interchangeable. F of x equals a negative x. And now we are all done with that example. Anytime you're asked for function notation, that means change your y to f of x, and everything else should stay the same. So f of x equals negative x. And now we are done with that example. So hopefully you feel confident with these concepts as we jump into some study guide practice today.